Now the haloalkanes and the haloarenes. Objective: after studying this unit, you will be able to know the haloalkanes and haloarenes according to the IUPAC system of the nomenclature from the given structure. Describe the reaction involved in the preparation of the haloalkanes and the haloarenes and understand the various reactions that they undergo. Correlate the structure of the haloalkanes and the haloarenes with the various types of the reaction. Use the stereochemistry as a tool for the understanding the reaction mechanism. Appreciate the applications of the organometallic compounds and highlight the environmental effects of the polyhalogen compounds. Now the halogenated compounds persist in the environment due to their resistance to the breakdown by the soil bacteria. The replacement of the hydrogen atom in an aliphatic or the aromatic hydrocarbon by the halogen atom result in the formation of the alkyl halide haloalkane and aryl halide haloarene, respectively. Haloalkanes contains the halogen atom attached to the sp3 hybridized carbon atom of the alkyl group, whereas the haloarenes contains the halogen atom attached to the sp2 hybridized carbon atom of an aryl group. Many halogen-containing organic compounds occur in the nature, and some of these are clinically useful. These classes of the compounds find bad applications in the industry as well as in their day-to-day life. They are used as a solvent for the relatively non-polar compounds and as starting materials for the synthesis of the wide range of the organic compounds. Choline-containing antibiotic chloramphenicol produced by the microorganisms is very effective for the treatment of the typhoid fever of our body. Produces iodine containing hormone thyroxine, the deficiency of which cause a disease called the goiter. Synthetic halogen compounds, namely the chloroquine, is used for the treatment of the malaria. Halothane is used as an anesthetic during the surgery. Certain fully polynated compounds are being considered as a potential blood substitute in the surgery. Potential blood substitutes in the surgery. In this unit, you will be study the important methods of the preparation, physical and the chemical properties, and the usage of the organohalogen compounds. Now the classification on the basis of the number of the halogen atoms. Haloalkanes and the haloarenes may be classified as the follow. These may be classified as the mono, di, or the polyhalogen, tri, tetra, etc. compounds depending on whether they contain one, two, or the more than halogen atoms in their structure. For example, monohaloalkane, dihaloalkane, trihaloalkane, monohaloarenes, dihaloarenes, and trihaloarenes. Monohalo compounds may further be classified according to the hybridization of the carbon atom to which the halogen is bonded as discussed below. तो सबसे पहले आता है इसमें compound containing the sp3c x bond x equal to fluorine coenbromine iodine. This class includes alkyl halides or the haloalkanes Rx. In an alkyl halides, the halogen atom is bonded to an alkyl group R. They form a homologous ridge represented by the CnH2n plus 1x. They are further classified as primary, secondary, and tertiary according to the nature of the carbon to which the halogen is attached. If halogen is attached to a primary carbon atom in an alkyl halide, the alkyl halide is called the primary alkyl halide or the 1-degree alkyl halide. Similarly, if the halogen is attached to the secondary or the tertiary carbon atom, the alkyl halide is called the secondary alkyl halide and the tertiary alkyl halide respectively. तो ये हो गया प्राइमरी 1 डिग्री, ये हो गया सेकेंडरी 2 डिग्री और ये हो गया टर्सरी 3 डिग्री. फिर अल्काइल हैलाइड. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom adjacent to the carbon-carbon double bond. That means an allylic carbon. तो ये हो गया एलाइलिक कार्बन और ये हो गया एलाइलिक कार्बन, यहाँ इसको भी कहेंगे एलाइलिक कार्बन. उसके बाद आता है बेंजाइलिक हैलाइड्स. तो these are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom attached to an aromatic ring. तो इसमें जो आता है वो आता है स्विच टू एक्स और द आर डबल वन स्विच 3 आर डबल वन एच 2 डिग्री और आर डबल वन आर आर स्विच 3 डिग्री वाला आता है. फिर कंपाउंड्स कॉन्टेनिंग sp2c(x) बॉन्ड. तो दिस class includes vinylic halides. These are the compounds in which the halogen atom is bonded to a sp2 hybridized carbon atom of a carbon-carbon double bond C double bond C. Or aryl halides. These are the compounds in which the halogen atom is directly attached bonded to the sp2 hybridized carbon atom of an aromatic ring. फिर आता है उसके बाद nomenclature कि Having learned the classification of the halogenated compound, let us now learn how these are named. The common names of the alkyl halides are derived by naming the alkyl group followed by the name of the halide. In the IUPAC system of the nomenclature, alkyl halides are named as the halosubstituted hydrocarbons for monohalogen substituted derivatives of the benzene. Common and the IUPAC names are the same. For the dihalogen derivatives, the prefix ortho, meta, para are used in the common system, but in the IUPAC system, as you have learned in the class 11, Unit 12, the numerals 1, 2, 1, 3 and the 1, 4 are used. Now the common name and the IUPAC name. N-propyl bromide and the 1 bromopropane, फिर isopropyl chloride and the 2 chloropropane. उसके बाद फिर आता है isobutyl chloride और the 1 chloro 2 methyl propane. फिर कॉमन नेम इसमें आता है ब्रोमोबेंजीन, इसमें आता है इसका भी ब्रोमोबेंजीन ही IUPAC नेम है. फिर मेटा ब्रोमोबेंजीन तो 1,3-डाइब्रोमोबेंजीन IUPAC नेम. और इसका है फिम ट्राइब्रोमोबेंजीन और IUPAC नेम 135 ट्राइब्रोमोबेंजीन. फिर उसके बाद IUPAC नेम इसका आ जाएगा 1 क्लोरो 2,2 डाइमिथाइल प्रोपेन, इसका 2 ब्रोमोप्रोपेन. The dihaloalkanes having the same type of the halogen atoms are named either alkylidene or the alkyline dihalides. The dihalo compounds having both the halogen atoms are further classified as the geminal halides or the gem dihalides when both the halogen atoms are present on the same carbon atom of the chain, and the bifunctional dihalide or the Bic dihalide when halogen atoms are present on the adjacent carbon atom. In common name system, gem dihalide are named as the alkylidene halides and the Bic dihalides are named as the alkyline dihalides. In the IUPAC system, they are named as the dihaloalkanes. तो कॉमन नेम हो गया इथाइलिडीन क्लोराइड, कॉमन नेम हो गया इथाइलिडीन क्लोराइड जिसको जेम डाइहालाइड कहते हैं, और इसका इथाइलिन डाइक्लोराइड जिसको भिक डाइहालाइड कहते हैं. तो इसका IUPAC नेम हो गया 1,1 डाइक्लोरो इथेन और इसका 1,2 डाइक्लोरो इथेन. तो सम कॉमन एग्जांपल्स ऑफ द हैलो कंपाउंड्स आर मेंशन इन टेबल 10.1. तो इसमें आता है फेक बुटाइल क्लोराइड और 2 क्लोरोब्यूटेन. फिर नियोपेंटाइल ब्रोमाइड तो 1 ब्रोमो 2 डाइमिथाइल प्रोपेन. फिर टर्ट बुटाइल ब्रोमाइड 2 ब्रोमो 2 मिथाइल प्रोपेन. फिर विनाइल क्लोराइड तो क्लोरोइथीन और एलाइल ब्रोमाइड तो 3 ब्रोमोप्रोपिन. फिर ऑर्थोक्लोरोटोलिन तो 1 क्लोरो 2 मिथाइल बेंजीन और 2 क्लोरोटोलिन. फिर बेंजाइल क्लोराइड तो इसका आता है क्लोरोफिनाइल मीथेन. फिर आता है मिथिलीन क्लोराइड तो इसका आएगा डाइक्लोरोमीथेन. फिर आता है क्लोरोफॉर्म तो इसका आएगा ट्राइक्लोरोमीथेन और इसका आएगा ब्रोमोफॉर्म तो ट्राइब्रोमोमीथेन. और कार्बन टेट्राक्लोराइड तो टेट्राक्लोरोमीथेन और 1 प्रोपाइल फ्लोराइड तो 1 फ्लोरोप्रोपेन आ जाएगा इसका. नाउ draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br. Name each isomer according to the IUPAC group and classify them as the primary, secondary or the tertiary bromide. तो ये हो गया 1 ब्रोमोपेंटेन, ये हो गया 2 ब्रोमोपेंटेन, ये हो गया 3 ब्रोमोपेंटेन और ये 1 ब्रोमो 3 मिथाइल ब्यूटेन. फिर ये हो गया 2 ब्रोमो 3 मिथाइल ब्यूटेन, ये हो गया 2 ब्रोमो 3 मिथाइल 2 मिथाइल ब्यूटेन, ये हो गया 1 ब्रोमो 2 मिथाइल ब्यूटेन और ये हो गया 1 ब्रोमो 2 डाइमिथाइल प्रोपेन. राइट द IUPAC नेम्स ऑफ द फॉलोइंग. तो पहले वाले का हो जाएगा इसका 1 4 ब्रोमोपेन 2 इन, इसका हो जाएगा 2 ब्रोमो 3 ब्रोमो 2 मिथाइल ब्यूटेन. फिर तीसरे वाले का आ जाएगा 4 ब्रोमो 3 मिथाइल पेन 2 इन. चौथे वाले का 1 ब्रोमो 2 मिथाइल ब्यूट 2 इन और पाँचवें वाले का 1 ब्रोमो ब्यूट 2 इन और छठे वाले का 3 ब्रोमो 2 मिथाइल प्रोपीन. फिर इन टेक्स्ट क्वेश्चन है कि राइट द स्ट्रक्चर ऑफ द फॉलोइंग कंपाउंड्स 2 क्लोरो 3 मिथाइल पेंटेन 1 क्लोरो 4 इथाइल साइक्लोहेक्सेन 4 टर्ट बुटाइल 3 आइडोहेप्टेन 1 4 डाइब्रोमो ब्यूट 2 इन 1 ब्रोमो 4 फेक बुटाइल 2 मिथाइल बेंजीन. फिर नेचर ऑफ द CX बॉन्ड. Halogen atoms are more electronegative than the carbon, therefore the carbon-halogen bond of alkyl halide is polarized. The carbon atom bears a partial positive charge, whereas the halogen atoms bears a partial negative charge. As we go down the group in the periodic table, the size of the halogen atom increases. Fluorine atom is the smallest and the iodine atom is the largest. Consequently, the carbon-halogen bond length also increases from the CF to CI. Some typical bond length, bond enthalpies, and the dipole moments are given in table 10.2. Alkyl halides are best prepared from the alcohols which are easily accessible. Now the common carbon halogen bond length, bond enthalpy and the dipole moment. तो ये दिया हुआ है CH3F का, CH3Cl का, फिर CH3Br का और CH3 आई का दिया हुआ है। इधर बॉन्ड लेंथ फिक्स बॉन्ड इंथैल्पी किलोजूल पर मोल में और डायपोल मोमेंट डेबी में दिया हुआ है। फिर मेथड फॉर द प्रिपरेशन ऑफ द हैलोअल्केन्स फ्रॉम द अल्कोहल से, तो the hydroxyl group of an alcohol is replaced by the halogen on reaction with the concentrated halogen acid phosphorus halide for the thionyl chloride. Thionyl chloride is preferred because in this reaction alkyl halide is formed along with the gaseous SO2 and HCl. The two gaseous products are escapable, hence the reaction gives the pure alkyl halides. The reaction of the primary and the secondary alcohol with the HCl requires the presence of a catalyst hydrogen Cl2 with the tertiary alcohol. The reaction is conducted by the simple sucking the alcohol with the concentrated HCl at the room temperature. Constant boiling with the HBr 48% used for the preparing alkyl bromide. Good yields of the Ri may be obtained on heating alcohol with the sodium or the potassium iodine in a 95% orthophosphoric acid. The order of the reactivity of the alcohols with a given halo acid is 3 degree, 2 degree, 1 degree. Phosphorus tribromide and the triiodide are usually generated in situ produced by in the reaction mixer by the reaction of red phosphorus with the bromine and the iodine respectively. तो ROH प्लस HCl ZnCl2 RCl प्लस H2 हो जाएगा। फिर ROH प्लस NaBr RBr प्लस NH4 प्लस H2 हो जाएगा। फिर ROH प्लस PX3 X इक्वल टू क्लोरीन ब्रोमीन हो जाएगा। फिर ROH प्लस PCl5 ये हो जाएगा और ROH एडेड फास्फोरस प्लस F2 RX हो जाएगा। ROH प्लस FeCl2 RCl प्लस FO2 प्लस HCl हो जाएगा। उसके बाद द प्रिपरेशन of the alkyl chloride is carried out either by passing dry hydrogen chloride gas through a solution of the alcohol or by heating a mixture of the alcohol and the concentrated aqueous halogen acid. The above mentioned are not applicable for the preparation of the aryl halides because of the carbon-oxygen bond in the phenols has a partial double bond character and is difficult to break, being stronger than a single bond. Now from the hydrocarbons, from the alkanes by the free radical halogenation. Free radical correlation or the bromation of the alkanes gives a complex mixture of the isomeric mono and the polyhaloalkanes which is difficult to separate as the pure compounds. Consequently, the yield of any single compound is low. जैसे CH3 CH2 CH2 CH3 और Cl2 UV light और the heat दिए तो ये बना और फिर ये बना. From alkenes, additions of the hydrogen halides, an alkene is converted to corresponding alkyl halides by the reaction with the hydrogen chloride, hydrogen bromide or the hydrogen iodide. जैसे HX तो यहाँ पर HX ऐड हो गया. Now the propene yields two products, however only one predominates as the per Markovnikov rule. जैसे कि C3CH1CH2 प्लस HI तो माइनर ये बनेगा और मेजर ये बनेगा. उसके बाद फिर एडिशन ऑफ हैलोजन, तो इन द लेबोरेटरी एडिशन ऑफ द ब्रोमीन इन द CCl4 to an alkene resulting in the discharge of the reddish brown color of the bromine constituent an important method for the detection of the double bond in the molecule. The addition result in the synthesis of the Vic dibromides which are colorless. तो Br2 CCl4 को ऐड करेंगे तो Vic dibromide बन जाएगा. इसके बाद एग्जाम्पल 10.3 आता है कि आइडेंटिफाई all the possible monochlorostructural isomers expected to be formed on the free radical monocorrelation CH3 CH CH2 CH3. So in the given molecule there are 4 different types of the hydrogen atoms. Replacement of these hydrogen atoms will give the following. तो पहला आता है halogen exchange. तो alkyl iodides are often prepared by the reaction of the alkyl chlorides bromides with the NaI in the dry acetone. This reaction is known as the Finkelstein reaction. इसमें RX प्लस NaI दे देगा RX प्लस NaI दे देगा Ri प्लस NaX, जहाँ X बराबर क्लोरीन और दी ब्रोमीन है. NaCl or the NaBr the format is precipitated in the dry acetone. It facilitates the forward reaction according to the Le-Chatelier principle. The synthesis of the alkyl fluorides is best accomplished by heating an alkyl chloride bromide in the presence of a metallic fluoride such as AgF, Ag2, F2, COF2, Fb, F3. This reaction is termed as the Schwarz reaction. Now the CH3Br plus AgF, CH3F plus AgBr. उसके बाद फिर आता है preparation of the haloarenes from the hydrocarbons by the electrophilic substitution. तो aryl chlorides and the bromides can be easily prepared by the electrophilic substitution of the arenes with the choline and bromine respectively in the presence of the Lewis acid catalyst like the iron or the iron 3 chloride. जैसे हो गया orthohalotolene, ये हो गया para-halotolene. The ortho and the para isomers can be easily separated due to the large difference in their melting point. Reaction with the iodine are reversible in the nature and require the presence of the oxidizing agent HNO3 HiO4 to oxidize the Hi formed during the iodination. Fluorocompounds are not prepared by this method due to the high reactivity of the fluorine. फिर आता है फ्रॉम एमाइन्स बाय द फैंड मेयर रिएक्शन व्हेन ए प्राइमरी एरोमेटिक एमाइन डिसॉल्व और सस्पेंडेड इन द कोल्ड aqueous mineral acid is treated with the sodium nitrate. A diazonium salt is formed. Mixing the solution of the freshly prepared diazonium salt with the cuprous chloride or the cuprous bromide results in the replacement of the diazonium group by the fuel or the Br. तो NH2 NaNO2 प्लस HF 273 से 278 के बन जाएगा तो क्या बनेगा, तो इसमें बन जाएगा बेंजीन डाईएजोनियम हैलाइड, बेंजीन डाईएजोनियम हैलाइड बन जाएगा। और फिर CuX2 तो एराइल हैलाइड इसमें बन जाएगा प्लस N2 बन जाएगा, जहाँ X बराबर क्लोरीन और द ब्रोमीन है। द रिप्लेसमेंट ऑफ द डाइजोनियम ग्रुप बाय द आयोडीन डाई नॉट रिक्वायर द प्रेजेंस ऑफ द cuprous हैलाइड एंड इट डन सिंपली बाय शेकिंग द डाइजोनियम साल्ट विद द पोटेशियम आयोडाइड। तो इसमें I प्लस N2 बन जाएगा। उसके बाद राइट द प्रोडक्ट्स ऑफ द फॉलोइंग रिएक्शन, जैसे HBr, तो और फिर उसके बाद HCl इसमें ऐड किए, फिर इसमें HBr और पेरोक्साइड ऐड किए, तो ये इसमें बन जाएगा, इसमें ये बन जाएगा और फिर इसमें ये बन जाएगा। उसके बाद आता है इन टेक्स्ट क्वेश्चन, वाई सल्फ्यूरिक एसिड नॉट यूज्ड इन द रिएक्शन ऑफ द अल्कोहल्स विथ Ki, राइट स्ट्रक्चर ऑफ द डिफरेंट हाइड्रोजन डेरिवेटिव्स ऑफ द प्रोपेन, among the isomeric alkanes of the molecular formula C5H12 identify the one that on photochemical condition yields a single monochloride, 3 isomeric monochlorides and 4 isomeric monochlorides. Draw the structure of the major monohalo products in each of the following reaction. तो पहला FOCl2 में, फिर HCl में, फिर C3C2BrNi में, फिर Br2 हीट और द UV लाइट में, फिर HI में और हीट और द UV लाइट में। इसके बाद आता है फिजिकल प्रॉपर्टीज। तो alkyl halides are the colorless when pure, however bromides and iodides develop color when exposed to the light. Many volatile halogen compounds have the sweet of smell. उसके बाद फिर melting and the boiling points, तो मिथाइल क्लोराइड, मिथाइल ब्रोमाइड, इथाइल क्लोराइड and the some chlorofluoromethanes are gases at the room temperature. Higher members of are liquids or the solids. As we have already learnt, molecules of the organic halogen compounds are generally polar due to the greater polarity as well as the higher molecular mass as compared to the parent hydrocarbon. The intermolecular force of the attraction dipole and the van der Waals are stronger in the halogen derivatives. That is why the boiling point of the chlorides, bromides and iodides are considerably higher than those of the hydrocarbon of the comparable molecular mass. The attraction gets stronger as the molecule get bigger in the size and have more electrons. The pattern of the variation in the boiling points of the different halides is depicted in the figure 10.1. For the same alkyl group, the boiling point of the alkyl halides decrease in the order Ri, फिर Rbr, फिर Rcl, फिर Rf. This is because with the increase in the size and the mass of the halogen atom, the magnitude of the van der Waals forces increases. इसमें आता है कंपेरिजन ऑफ द बॉइलिंग पॉइंट्स ऑफ द सम अल्काइल हैलाइड्स दिया हुआ है, क्लोराइड्स दिया हुआ है, ब्रोमाइड्स दिया हुआ है और आयोडाइड्स दिया हुआ है। तो द बॉइलिंग पॉइंट्स ऑफ द आइसोमेरिक हैलोअल्केन्स डिक्रीजेज विद द इंक्रीज इन द ब्रांचिंग। फॉर एग्जांपल 2-bromo-2-मिथाइल प्रोपेन है द लोएस्ट बॉइलिंग पॉइंट अमंग द 3 आइसोमर। इसका बॉइलिंग पॉइंट 375 है, इसका 364 है, इसका 340 है। बॉइलिंग पॉइंट्स ऑफ द आइसोमेरिक डाइहैलोबेंजीन्स आर वेरी नियरली द सेम, हाउएवर द पैरा आइसोमर्स आर high melting as compared to the ortho and the meta isomers. It is due to the symmetry of the para isomers that fits in the crystal lattice better as compared to the ortho and the meta isomers. इसके बाद आता है फिर डेंसिटी। इसका ऑर्थो वाला का बॉइलिंग पॉइंट 453 है और 440 है और इसका 448 है। तो बॉइलिंग पॉइंट अगर देखें तो सबसे ज़्यादा आता है, सबसे ज़्यादा बॉइलिंग पॉइंट है ऑर्थो वाला का, उसके बाद फिर आता है पैरा का और फिर आता है मेटा का। और मेल्टिंग पॉइंट देखें तो सबसे ज़्यादा आता है पैरा का, फिर आता है ऑर्थो का और फिर आता है मेटा का। तो बॉइलिंग पॉइंट में सबसे ज़्यादा आता है और सबसे ज़्यादा आता है ऑर्थो, फिर आता है पैरा, फिर आता है मेटा और मेल्टिंग पॉइंट में पॉम आता है, मेल्टिंग पॉइंट में पॉम आता है। यह है मेल्टिंग पॉइंट का ऑर्डर। तो डेंसिटी, bromo, iodo and the polychloro derivatives of the hydrocarbon are heavier than the water. The density increases with the increase in number of the carbon atoms, halogen atoms and the atomic mass of the halogen atoms. तो कंपाउंड दिया हुआ है और दिया हुआ है N C3H7Cl, C3H1Br, C3H7HI। उसका डेंसिटी दिया हुआ है, कंपाउंड दिया हुआ है और डेंसिटी इन द ग्राम पर ml दिया हुआ है। फिर आता है solubility. The haloalkanes are very slightly soluble in the water. In order to dissolve haloalkanes in the water, energy is required to overcome the attraction between the haloalkanes between the haloalkane molecules and break the hydrogen bonds between the barter molecule. Less energy is released when new attractions are set up between the haloalkane and the barter molecule, and these are not as strong as the original hydrogen bonds in the barter. As a result, the solubility of the haloalkanes in the barter is low. However, the haloalkanes tend to dissolve in the organic solvents because the new intermolecular attraction between the haloalkanes and the solvent molecule have much the same strength as the one being broken in the separate haloalkane and the solvent molecule. फिर आता है इन टेक्स्ट क्वेश्चन के अरेंज each set of the compounds in order of the increasing boiling points. पहले ब्रोमोमीथेन, ब्रोमोफॉर्म, क्लोरोमीथेन एंड डाइब्रोमोमीथेन, फिर 1 क्लोरोप्रोपेन इफ आइसोप्रोपाइल क्लोराइड, 1 क्लोरोब्यूटेन. फिर केमिकल रिएक्शंस आता है. The reaction of the haloalkane may be divided in the following categories. पहला nucleophilic substitution, elimination reaction और reaction with the metals. फिर आता है nucleophilic substitution. You have learnt in the class 11 that nucleophiles are electron-rich species. Therefore, they attack at the part of the substrate molecule which is electron deficient. The reaction in which a nucleophile replaces already existing nucleophile in a molecule is called a nucleophilic substitution reaction. Haloalkanes are substrate in this type of reaction. A nucleophile reacts with the haloalkane, the substrate having a partial positive charge on the carbon atom bonded to the halogen. A substitution reaction takes place and halogen atom called leaving group departs as halide ion. Since the substitution reaction is initiated by a nucleophile, it is called a nucleophilic substitution reaction. तो Nu plus Cx यहाँ पर हो जाएगा CNu plus X minus, और it is one of the most useful class of the organic reactions of the alkyl halide in which halogen is bonded to sp3 hybrid carbon. The products formed by the reaction of the haloalkanes with some common nucleophiles are given in table 10.4. फिर आता है न्यूक्लियोफाइल सब्स्टिट्यूशन ऑफ द अराइल हैलाइड. Rx प्लस Nu बन जाएगा हमारा Ru प्लस X. उसके बाद फिर आता है न्यूक्लियोफाइल सब्स्टिट्यूशन प्रोडक्ट Rnu, अ क्लास ऑफ द मेन प्रोडक्ट. तो NOH OH माइनस है, सब्स्टिट्यूशन प्रोडक्ट ROH हो गया. फिर H2O में H2O है और ROH है. NOR में OR है और ROR बन जाएगा. फिर Na में I माइनस है, RI बन जाएगा. NH2 में NH3 है, RNH2 बन जाएगा. RNH2 में RNH2 RNHR बन जाएगा. फिर RNH में RRNH, फिर R डॉट बन जाएगा. केसियन में C माइनस है तो RCN बन जाएगा. फिर AgCN है तो RNC बन जाएगा, आइसोसाइनाइड बन जाएगा. और KNO2 में ONO जुड़ेगा तो RNO आके जुड़ेगा, और AgNO2 में ONO तो RNO2 बन जाएगा. इसमें ONO है, इसमें ONO है. उसके बाद फिर R Ag में R माइनस तो R बन जाएगा. फिर LiLH4 में H तो RH बन जाएगा, और RM में R जुड़ेगा तो RR बन जाएगा. तो जो मेन है वो है कि AgCN में Ag जुड़ेगा तो RCN बन जाएगा, इसको आइसो नाइट्राइल कहेंगे. फिर KNO2 में ONO जुड़ेगा तो RNO, इसको अल्काइल नाइट्राइल कहेंगे. फिर KCN में CN जुड़ेगा तो RCN, इसको नाइट्राइल कहेंगे. और उसके बाद फिर AgNO2 में जुड़ेगा तो नाइट्रो अल्केन कहेंगे. उसके बाद फिर आता है groups like the finite and the nitrile posit 2 nucleophilic center and are called the ambident nucleophiles. Actually, finite group is a hybrid of the two contributing structure and therefore can act as a nucleophile in two different ways, C double bond N and the N double bond C, linking through the carbon atom, resulting in the alkyl phenides, and through the nitrogen atom leading to the isophenides. Similarly, nitrite also represents an ambident nucleophile with two different points of the linkage. The linkage through oxygen results in the alkyl nitrites, and through the nitrogen atom it leads to the nitroalkanes. For example, 10.5 आता है कि haloalkanes react with the cation to form the alkyl phenides as main product, while AgCN forms isophenides as the chief product. Explain. So cation is predominantly ionic and provides cyanide ions in the solution. Although both carbon and the nitrogen atoms are in a position to donate d electron pairs, the attack takes place mainly through the carbon atom and not through the nitrogen atom, since the CC bond is more stable than the CN bond. However, AgCN is mainly covalent in nature and nitrogen is free to donate the electron pair to forming isophenide as the main product. इसके बाद फिर आता है mechanism. तो this reaction can be found to be performed by two different mechanisms which are described below. पहला substitution nucleophilic bimolecular FN2. The reaction between the C3Cl and the hydroxide ion to yield methanol and the chloride ion follows second order kinetics. That means the rate depends upon the concentration of both the reactants. फिर आता है, you have already learnt in the section 12.3.2 of the class 11, the solid base represents the bond coming out of the paper, dashed line going down the paper, and the straight line representing the bond in the plane of the paper. The above reaction can be repeated diagrammatically as shown in the figure 10.2. फिर the red ball the red ball represents the incoming hydroxide ion and the green ball represents the outgoing halide ions. In the year 1937, Edward David Hughes and Sir Christopher Ingold proposed a mechanism for an FN2 reaction. It depicts a bimolecular nucleophilic substitution FN2. The incoming nucleophilic interacts with the alkyl halides, causing the carbon halide bond to break, and a new bond is formed between the carbon and the attacking nucleophile. Here it is CO bond formed between the C and the OH. These two processes take place simultaneously in a single step, and no intermediate is formed. As the reaction progresses and the bond between the incoming nucleophile and the carbon atom starts forming, the bond between the carbon atom and the leaving group weakens. As this happens, the three carbon hydrogen bonds of the substrate start moving away from the attacking nucleophile. In the transition state, all the three CH bonds are in the same plane, and the attacking and the leaving nucleophiles are partially attached to the carbon. As the attacking nucleophile approaches closer to the carbon, CH bonds still keep on moving in the same direction till the attacking nucleophile attached to the carbon and leaving group leaves the carbon. As a result, configuration is inverted. The configuration of the carbon atom under the invert attack inverts in much the same way as an umbrella is termed inside out when caught in a strong wind. This process is called as the inversion of the configuration. In the transition state, the carbon atom is simultaneously bonded to the incoming nucleophile and the outgoing leaving group. Such structures are unstable and cannot be isolated. Thus, in the transition state, carbon is simultaneously bonded to 5 atoms. Now, the configuration. The special arrangement of the functional group around the carbon is called its configuration. See the structure A and B given below. तो mirror है, these are the two structure of the same compound that differ in the special arrangement of the functional group attached to the carbon. A structure A is mirror image of the structure B. B say configuration of the carbon in the structure A is mirror image of the configuration of the carbon in the structure B. Hughes worked under the Ingold and earned a DSc degree from the University of the London. Now, since the reaction requires the approach of the nucleophile to the carbon bearing the leaving group, the presence of the bulky substance on or near the carbon atom have a dramatic inhibiting effect of the simple alkyl halides. Methyl halides react most rapidly in the FN2 reaction because there are only 3 small hydrogen atoms. The free halides are the least reactive because bulky group hinders the approaching nucleophiles. Thus, the order of the reactivity follows primary halide, फिर secondary halide और फिर tertiary halide. तो steric effects in FN2 reaction, the relative rate of the FN2 reaction is given in the parenthesis. तो सबसे पहले मिथाइल, फिर उसके बाद इथाइल, आइसोप्रोपाइल और थर्ड ब्यूटाइल 3 डिग्री का दिया हुआ है. फिर आता है सब्स्टिट्यूएंट न्यूक्लियोफिलिक यूनिमोलिकुलर रिएक्शन FN1. FN1 reactions are generally carried out in the polar protic solvents like the water, alcohol, acetic acid, etc. The reaction between the tert-butyl bromide and the hydroxide ion yields the tert-butyl alcohol and follow the first order kinetics. That means the rate of the reaction depends upon the concentration of only one reactant, which is tert-butyl bromide. So 2-bromo 2-methyl propane हो गया. It occurs in 2 steps. In step 1, the polarized CBr bond undergoes slow cleavage to produce a carbocation and the bromide ion. The carbocation thus formed is then attacked by the nucleophile in the step 2 to complete the substitution reaction. इधर 2-methyl propane 2OL आ गया. फिर आता है इसमें CH3BC और OH माइनस. तो OH यहाँ पर आके जुड़ गया. फिर यहाँ पर CH3CBr है स्टेप 1 में, तो यहाँ पर Br माइनस और OH माइनस यहाँ पर CH3COH आके जुड़ गया. फिर आता है स्टेप 1. Step 1 is the slowest and reversible. It involves the CBr bond breaking of for which the energy is obtained through the solution of the halide ion with the proton of the protic solvent. Since the rate of the reaction depends upon the slowest step, the rate of the reaction depends only on the concentration of the alkyl halide and not on the concentration of the hydroxide ion. Further, greater the stability of the carbocation, greater will be its of formation from the alkyl halide and is faster will be the rate of the reaction. In case of the alkyl halides, 3-degree alkyl halides undergo FN1 very fast because of the high stability of the 3-degree carbocation. We can sum up the order of the reactivity of the alkyl halides towards FN1 and FN2 as follows. For the FN2 reaction, टर्सरी हैलाइड, सेकेंडरी हैलाइड, प्राइमरी हैलाइड और CH और फिर FN2 के लिए फॉर FN1 रिएक्शन के लिए ये दिए हुए। फॉर द सेम रीजन एलाइलिक एंड द बेंजाइलिक हैलाइड शो हाई रिएक्टिविटी टुवर्ड्स द FN1 रिएक्शन, द कार्बोकेटाइन फॉर्मेट गेट्स स्टेबलाइज्ड थ्रू द रियोनेंस शोन बिलो। इसके बाद फिर आता है फॉर एन अल्काइल हैलाइड, फॉर एन अल्काइल ग्रुप द रिएक्टिविटी ऑफ द हैलाइड आर एक्स फॉलो द सेम ऑर्डर इन बोथ द मैकेनिज्म RI, RBr, RCl एंड द RF। फिर आता है इन दी फॉलोइंग पेयर्स ऑफ द हैलोजन कंपाउंड्स विच वुड अंडरगो द FN2 रिएक्शन फास्टर। तो इसमें और इसमें, तो इन दोनों में ये वाला होगा कि इट इज प्राइमरी, क्योंकि इट इज प्राइमरी हैलाइड एंड देयरफॉर अंडरगो द FN2 रिएक्शन फास्टर। फिर इन दोनों में ये वाला आई वाला हो जाएगा, क्योंकि एज आयोडीन is a better living group because of its large phi, it will release at a faster rate in the presence of the incoming nucleophile। फिर एग्जाम्पल 10.7 दिए हुए।